And we're ready to go over the worksheet for section 1A, the Math 4 course. And I still enjoy that. I don't know, I still remember the artwork down in South America. Somebody taped a banana to a wall and they were bidding $100,000 on it. So I guess, maybe she was trying to raise the money, taping it to her face, who knows. In any case, we'll move on. Question number 1. And, the good news is that the questions were consistent. It's just the graphs that changed. So let's take a look at each graph. So the domain starts where x is -3 and stops where x is 14. And because you have a point on each end, you get a bracket, -3 to 14. There is no question where it stops, so you put a bracket there. Now, the range goes from -5 down here to +10 up there. This pretty much is the full range of this graph right here. So our range is it's a dot where y is -5. And it does reach up here. There is a point there at the very top. So it does count as a y value. So we're going to go from -5 to +10. And there is a clear point on both ends. Now, for the x-intercepts, we can look at the dot that's labeled there. That is 4.50. The y-intercept is down here, where y is -3. And so we're going to say 0, -3. If you ever get lost in writing the ordered pairs of these guys and you forget, does it go on the left or on the right? Well, think of it this way. An x-intercept is going to have an x number, and it should go where x goes. A y-intercept is going to have a y number, and it should go where the y goes. That's one way to keep them straight. Now, the maximum and minimum, we're talking about y values here. All right, we're talking about y values. So the maximum y value up here is 10. That's where the 10 is there. So our max value is 10. Our minimum value is down here where y is -5. Now the negative, I guess I should put the -3 up there so as not to be confused with the -5 that is the y value down here. And so that is what the first 6 should look like on this graph. Now for the next step, our thinking changes just a little bit. Because now we're talking about increasing and decreasing, which when we are talking about those, we're watching what y does up and down. But when we write our answer is terms of what x is doing. For instance, x starts at -3, where this starts, and it goes up and it goes up and it goes up and it reaches this point, which is actually 9. And it kind of maxes out up there. And then it drops down, and now it's decreasing on this side. And it gets to that point right there, which is actually 11. And then it hits a valley and then starts going back up again. And it goes up until it reaches 14. So that gives us our parameters here. It's increasing from -3 to 9. It's decreasing from 9 to 11. And then it's increasing from 11 to 14. Now, the same discussion we had in the notes is that when you're at the top of the mountain or whether you're at the bottom of the valley, you are not going up or down. You are not increasing, you're not decreasing, which means that, for instance, the point where y is 9 up here, that is neither increasing or decreasing. Where y is 9, it does not count on either side. So we're going to say we are increasing. We can point to here and say it starts down here where it's -3. But by the time it gets up to 9, 9 is a place where it's not going up or down. So I got to put a rounded circle. It's like an open circle up there. And then decreasing, I pick up from 9 and I go over to 11. And I have the same problem in the valley. 11 is neither increasing nor decreasing. So I do that. And then as I'm increasing again, I've got 2 places where I'm increasing. So I'm going to do that. And I stop at 14. There's a clear stopping point there. So I get a bracket there. I will say this about the parentheses and the brackets. If you're trying to memorize a pattern, oh, the brackets always go on the outside. No, they don't. They go wherever they need to go, okay? If you try to memorize a consistent pattern where brackets always happen here and parentheses always happen there, you're going to mess up because that's not the way to do it. Now, I will say this, anything that involves infinity, negative infinity or positive infinity, always gets a curved bracket, a curved parenthesis, rather. That will always happen. But as far as these points are concerned, either they are involved in the solution, or when they top out like this, they don't, because they're not going up, they're not going down. All right, positive and negative. That is a different animal. Okay, positive and negative. Positive is basically anything above the x-axis. That's positive, that's negative, which means that, and we're still playing that same game. We're watching what y is doing. Is it positive? Is it negative? But we're writing what x is doing. So x starts from -3 here. Make that a little bit larger. -3 here. And it is positive up until we reach this point, 4.5. And then from 4.5 on, the rest of it is all positive. It's all up here, all the way until we get to 14. But now there is an important discussion right here, right where 4.5 is. When x is 4.5, y is 0, right? It says so right there in the ordered pair. Does that make it positive or negative? And that's the problem. When y is 0, it is neither positive nor negative. So we're going to wind up with kind of an open circle going on right there. It's going to be from -3 all the way up to 4.5, but not including it. And then we'll start simply on the other side of 4.5 and go to 14. So we do know that it starts at -3. We can include 4.5, so we give it a rounded bracket, a rounded parenthesis. And then we do the same starting on the other end. Oops. I gotta do that up here. But yeah, I guess I was sort of right. I just got to watch where I place this stuff. And then 4.5 goes all the way up to 14, and there is a clear stopping point there. So that's what that's going to look like. Now, normally in behavior, most of the questions you're going to face in a quiz or a test, you're going to see where the ends of the graph are just zooming off into infinity. But this is one of the rare occasions where x is not going to approach infinity. It's going to approach -3 and stop there. So we're going to say as x approaches -3, what is y doing? Y is dropping down to -5, and that is as far as it gets. So that's going to be the negative side of the graph. On the positive side, x is not going to get any larger than 14. And when x approaches 14, y is going to get close to what looks like 7 there. Now, somebody may look at this and say, but wait a minute, Mr. G, doesn't y get bigger over here? Doesn't y reach 10? Why are we ignoring the 10? And the answer is the word that they asked for, end behavior. We don't care what else happens in the middle. We just care what happens at the ends. So that's the short answer for that one. Now, let's move on to another one. Okay. Now here, this is a graph which as it's going up, it's also going out in both directions. So the domain is still going to stay, well, the domain is going to be negative infinity to positive infinity. The range, the y's are going up, but they don't get any lower than 0. So the range is going to have 0 as a definite low point and infinity as its infinite high point. All right, X-Intercepts. Let's see now, we got one here at -2, and we got here at 1. And we're going to say -2, 0, 1, 0. The y-intercept is happening right there where it is 1, 2, 3, 4. The maximum, it's going forever up. The maximum is infinity. The minimum, we said y does not get any lower than 0. Okay. Then we move on to the next one. We get to the increasing and decreasing. Now here, it is decreasing from negative infinity all the way up to -2. And then it starts increasing again up until -0.5. And then it starts decreasing again until we get to +1. And then from there it goes on to infinity. So those are the stopping points. Is negative infinity to -2, that is decreasing. And remember, every time that you hit a valley or a mountaintop, it's not going up, it's not going down, so you're not going to put a bracket there. All right, increasing from -2 to -0.5, it is increasing. And then from -0.5 back down to 1, it is decreasing again. And then we are increasing at the very end from 1 onto infinity. So those are decreasing and increasing. And again, we're paying attention to what y is doing, but we're following, we're writing what x is doing. All right. Now, let's change gears with this for positive and negative. Actually, this is going to be kind of easy because no part of this graph lives below the x-axis. Nothing is negative. So negative is going to be, I'll switch colors here. Negative is going to be the null set. Now, as far as positive, all of this is positive except where x is -2 and where x is 1. Those two spots where it touches on the axis, well, that's where y is 0, and so they're not positive. So everything up here with those two spots is going to be positive. So we're going to say from -infinity We're just going to work our way left to right to -2, parenthesis, union, -2 to 1, parenthesis, union, 1 to infinity. So that deals with all three chunks. The left chunk up to -2, the middle chunk up to 1, and then from 1 to infinity. And all three of them are covered. All right, end behavior, they're both going up forever, right? So here's how we're going to write this. We're going to say as x is approaching -infinity, and as x is approaching positive infinity. We're going to have two statements like that. But in both cases, y is going up, y is going toward positive infinity in both cases. So our answer is going to look like that. This, honestly, is going to be what more of your questions on quizzes and tests are going to be at this level. I'm usually going to be giving you graphs that go off the scale. Okay. Now, let's do a different graph. All right. The domain goes on forever in both directions. And for that matter, so does the range. The X-intercepts are at -2 and at +3. The Y-intercept is up here at +3. The maximum is infinity, and the minimum is infinity. As this side's going up forever. Actually, yeah, when it goes up this way, y goes forever. When it goes this way, y goes forever. So I guess the minimum would be -infinity. Let's be correct on that. Okay. With increasing and decreasing, it is decreasing up to -2, from -infinity to -2, and then it starts increasing from -2 to about 1.3. We'll round it there for the sake of ease. And then once you get past 1.3, it goes down forever. So that is positive infinity from there on. So we are decreasing in the first segment and the last segment, and we're increasing in the middle. All right, so increasing in the middle would be from -2 to 1.333, and then we're decreasing from -infinity to -2, union with the 1.33 to infinity. All right, and then as far as positive and negative, you're actually going to have an added point right here at 3. That we are positive all the way up here to 3, except for that spot on -2. We're going to go from -infinity to -2, and then pick up on the other side of -2 and go all the way to 3. We're still staying positive. And then negative is from 3 to infinity. And then the end behavior, I'm going to start as x approaches negative infinity and y approaches, and we'll figure that out in a second, as x approaches positive infinity, y, as x is approaching negative infinity, y is going up, y is going toward positive infinity. As x approaches positive infinity on the right side, it's going down, which means x is heading toward negative infinity. You know how the beginning of the sentence is going to be in most of these. As x approaches negative infinity, as x approaches positive infinity. Those two sentences will stay the same for the most part. It's just that you got to watch, is my y going up or down on that side and on this side. All right. Now, here, this is an absolute value function. It's actually more like the absolute value of 2x because it's not, as much of a v. It's stretching more than it ought to. But in any case, we know that it's going that way forever and going that way forever. And so that means the domain is going to include everybody. The range never gets below +1. And it does touch +1, so he gets a bracket. And then a infinity on the other end. The X-intercepts, there are none. The Y-intercept, there's 1 at 5. The maximum goes on to infinity. And the minimum drops down as low as y is -1, y is +1. That is going to be your max and your min for this situation. For the next set, these actually answer pretty easy. All the way up to where x is 2. It is decreasing to 2, and it is increasing beyond that. So we'll say it is decreasing from negative infinity to +2. And of course, we can't include the valley. And then it's increasing from 2 to positive infinity. Now, meanwhile, when we start asking about positive and negative, is any part of this graph below the x-axis? No, there is no part of this that is negative. On the other hand, every bit of it is above the axis, so all of it is positive. Now, where do my x's go? From negative infinity down here, and then out to positive infinity? It's the whole domain. So where is it positive? From negative infinity to positive infinity. All right. So next we talk about endpoint behavior, and on both ends, when x is negative and when x is positive, it's still going up for y. So we're going to say y approaches infinity, y approaches infinity. Okay. Now, these next couple should be kind of easy. This is a straight line. Now, if my projector weren't scrunching it and making a trapezoid out of this, this would have a slope of what looks like down 1 and over 4. But in any case, the domain goes on forever. The range goes on forever. So all right, X-Intercepts. Well, you know, you could probably plot this. And say if it goes down 1 and over 4, it's going to go from 5, 0 to 4, 4, down 1 over 4. No, excuse me, 0, 5. You're not given the rest of this, but you can actually work it out. Then it's going to be 8 and 3, and then 12 and 2, and then 16 and 1, and then 20 and 0. So your X-intercept is going to wind up being 20 and 0. Again, all I was doing was simply following the pattern. From 0, 5 to 4, 4 to 8, 3, I'm gaining 4 on the X and losing 1 on the Y. And so I'll leave that there. The Y-intercept is clearly 0, 5. And when we start talking about maximum and minimum, it's going on forever, forever up, forever down. So the maximum is infinity and the minimum is negative infinity. Okay. Now, increasing. There is no increasing. And every bit of it is decreasing from negative infinity to positive infinity. Now, we said that the X-intercept was at 20, 0, didn't we? That's where it crosses the line and becomes negative, right? So anything to the left of 20 is going to be positive, it's going to be up here, but anything after the point 20, 0 is going to be below the x-axis, and it's going to be negative. So our positive is going to be from negative infinity up through where x is 20, and then our negative is going to be 20 all the way to positive infinity. The end behavior asking the same questions as x approaches each infinity. What is y doing? As x approaches negative infinity, y is going up. As x approaches positive infinity, y is going down. Now, if I'm not mistaken, this is our last one. We have an exponential curve. So it's going to do a little something different. Our domain is still going to be forever in both directions. But as far as the range goes, it is never going to drop below the x-axis. That's one of the things about a exponential function like that, is that it can never be 0, it can never be negative, at least not in standard form. So it's not going to get any lower than 0. It will never touch 0 but the range will go forever up toward infinity. Now, X-intercepts, we have the same problem. It will never touch the X-axis. So there are no intercepts, and there's one Y-intercept. Now, take a good look at the markings. There are 2 notches there, but there's also a 2 up above it. That means that this is actually 1. So my Y-intercept is at 0, 1. Be careful of that. Be careful of reading a graph and assuming that every notch counts for 1. In this case, every notch counts for a half. All right, the maximum value for Y is going to keep going up forever. The minimum value for Y, Y must be greater than 0. I'm going to list it that way, because as soon as you start trying to figure out how low can you go, well, there's always something lower than that that's between that and 0. So we're just going to say Y never quite reaches 0. Y must be greater than 0. That's one of the rare occasions you'll step in and throw in a Y in the answer like that. All right, next step. Technically, this is always increasing. All the way from negative infinity to positive infinity, it is always increasing. It is never decreasing. Since it stays above, it is always positive, the entire graph, and it is never negative. Now, here's where we have to make one little tweak. As x approaches negative infinity, y is approaching what? The further out that way you go, what is y doing? Y is getting closer and closer to 0, isn't it? You're going to do that. And when you go the other way, y is approaching positive infinity. I believe. Yeah, that was the last one. So that is the worksheet for 1A, and I should have the notes for 1B ready very soon.